Hello, General Science. So today we're going to have another video about atoms, isotopes, and ions. It's just to clarify some common mistakes I've seen over the last 2 weeks. I've seen a lot of great work, but I just wanted to clarify a few things, and I wanted to give you some more help before your quiz on Wednesday. So let's get started. So just a review for atoms, isotopes, and ions. The number of protons is our atomic number, straight from the periodic table of elements. Our mass of an atom is the number of protons plus the number of neutrons, and our charge of an atom is the number of protons minus the number of electrons. Now remember, it's minus the number of electrons because those electrons are negative. They are negative. Isotopes are the same element, but they have a different mass, so they have a different number of neutrons. Ions are the same element, but have a different charge, meaning they have a different number of electrons. So all atoms of the same element must have the same number of protons, but they do not have to have the same number of neutrons or electrons. So let's take a look at some examples. So first, before we look at examples, we have to know how to read an atom properly. So if you have, where's my mouse? There we go. If you have the symbol plus these three numbers, what these three numbers are. So this is the symbol of the element, K for potassium. This upper left-hand corner, this is going to be the mass of the atom. So in this case, potassium is 40, has a mass of 40. The atomic number of this atom is going to be 19. And the charge, if it's not zero, so if it's zero, there might not even be anything there. But if it's not zero, the charge will be here. And in this case, the charge is +1. From this, we can figure out how many protons, neutrons, and electrons there are. So let's start with protons. Protons is the easiest. We've got an atomic number. Atomic number is the same as our number of protons. So there we go, 19. Atomic number 19, number of protons, 19. Let's move ahead to our mass number. Our mass number is going to give us our number of neutrons. So if you recall, our mass is our number of protons plus our number of neutrons. Well, we've got our mass is 40. Our atomic number is 19, meaning our number of protons is 19. We've got 40 equals 19 plus your number of neutrons. If you do some math there, we get our number of neutrons is 21. 40 minus, oh, where's my mouse? There we go. 40 minus 19 is 21. So we have 21 neutrons. Let's think about electrons now. So we have a charge of +1. So the charge equals the number of protons minus the number of electrons. So if we have 1, positive 1 equals 19 minus number of electrons, our number of electrons must be 18. So it's +1, we have 1 less electron than proton. All right, let's take a look at some other examples now. Here we have carbon, C for carbon, C for carbon. We have no charge, no charge. If there's nothing here, we have no charge. So number of protons, our atomic number down here is going to be our number of protons. So we have 6 protons. Here we have our mass is 12. 12 minus 6 is going to give us 6, so we have 6 neutrons. 6 protons, 6 neutrons, and then if we have a charge of 0, you may recall that when 0 is our charge, our electrons equal our protons. So if we have 6 protons, we will have 6 electrons. In this example of carbon, we have 6 protons, 6 neutrons, and 6 electrons. Let's take a look at another example. Here we have chlorine. Chlorine, atomic number 17, atomic mass 35, and charge, it just says minus. Well, if there's just a minus here, we can assume that this is a -1. So if there's just a minus or just a plus, we can assume that that is a 1. So we've got our atomic number down here, 17, that means we've got 17 protons. This atomic number is always your number of protons. Let's move on. Here's our atomic mass. Here's our mass. It's 35, so we need to figure out number of neutrons. We're going to take our mass and subtract our number of protons. So 35 minus 17, that gives us 18. So we have 18 neutrons here, 18 neutrons, 17 protons, 18 neutrons, and with this minus charge, so minus 1, this means we're going to have one more electron than proton. So we're going to have 17 protons, 18 neutrons, and if we have one more electron than proton, we're also going to have 18 protons. So 17, 18, and 18. Let's take a look at one last example of magnesium. We've got a atomic number of 12. You should know by now this means our number of protons is 12. 12 protons. Our mass here is 24. You should know mass minus number. Mass minus number is neutrons. So we've got 24 minus 12 giving us 12 neutrons. So we have 12 protons and 12 neutrons. Now over here, our charge, we have a charge of 2+. So if we have a charge of 2+, so it's going to be 2 equals protons minus electrons. We have 12 protons. So 2 equals 12 plus the number, 2 equals 12 minus the number of electrons. That means our number of electrons must be 10. We're going to have 2 less electrons than protons, so they're going to be 10 electrons. So we have 12 protons, 12 neutrons, and 10 electrons. All right, so ladies and gentlemen, you have an ed puzzle to complete that's about an isotope and an ion of an atom. This functions as review for Thursday's quiz. So we do have a quiz on Thursday. So if you have any questions or concerns about anything, feel free to email me, let me know. We have office hours on Wednesday, and if you're confused about any of this, I very much recommend coming to office hours on Wednesday because we can work through some of these examples together. All right, ladies and gentlemen, have a good weekend, and I'll talk to you later.